Hey everybody, so thanks for joining us at Geothermal House Austin. I know a lot of you, but for you all that are not familiar with Project Innerspace, we are a nonprofit organization that is dedicated to getting geothermal on an exponential growth curve really fast. So we are technology agnostic. We are neutrals that are trying to bring together often polarized entities to push geothermal forward. And we're trying to do it really fast. So we're on a sprint to try to get geothermal in a fast pitch growth by 2030. So we're on a countdown. We're a decade long sprint. So one thing I wanted to do before we kick into the panels today, and there's a bunch of different topics that we're going to explore with a lot of different panelists. One thing that we've heard in geothermal houses as we traveled around in this series is that when we jump into the sessions, we actually automatically leave people behind because the panelists are really deep in their subject matter expertise, and they start using all kinds of they use a lot of terminology that's unfamiliar. They start talking about different technologies, and there's not really enough basics to get people up to speed. So what I'll do for a few minutes is the basics. What is geothermal? Why is this important? How are we going to scale it? And a really brief overview of what the technologies look like and why this is new. What's new in the space and why it's growing and why you're hearing about it more, why it's gotten buzzy. So we'll spend a few minutes on that, and then it'll kind of get you to a place, I think, where we can start jumping into the content and the panels, and you'll be able to follow the conversations a little bit if you're not familiar with geothermal. If you are familiar with geothermal, sit back, get a beer, and hang with me for 15 minutes. So here we go. Geothermal. The core of the Earth is the temperature of the surface of the sun. So it's really freaking hot. It's 6,000 degrees Celsius. And all of that heat has to go somewhere, but it doesn't leak out into the atmosphere so much that we burn our feet when we walk around, right? So when you walk around barefoot on the ground, it doesn't feel hot. What that means is that the crust is an incredible insulator, and it keeps all of that heat inside, right? So it's really, really hot the further you go down underground. A lot of oil and gas drillers know this because when they drill for oil and gas, the oil and gas is actually almost boiling in some places when they produce it. So the further you go down, the hotter it goes. This is everywhere in the world, right? One of the myths about geothermal is that it's limited. It's just in a few places in the world. Think of Iceland. So when you say geothermal, a lot of people will say, oh, right, a hot spring, that's where I hung out on vacation, or volcanoes, right? No, not just that. Geothermal for the last 100 years has been just that, and there's a specific reason for that. The technologies that allow us to drill for geothermal have been limited, and we'll talk about this a little bit later in the presentation, but there's a lot of really new, interesting technological development that's happened that allows us to drill for geothermal in many more places in the world, not just Iceland. But if you think about Iceland and volcanic regions, there are specific geologies and specific characteristics of those places that make geothermal really easy to get to. There's hot, it's heat, it's very shallow, it's a volcanic region, it's porous rock. So you've seen like lava rock, it's got a lot of holes in it. So there's a lot of holes in the underground, and it's full of water. So obviously, you drill, you can drill it really easily, you can produce heat or electricity, and in places like Iceland, geothermal is ubiquitous, it's everywhere. But the thing that's new and cool in the last 20 or so years has been the technological flourish of the shale boom in oil and gas. So what you're seeing on the screen it's a mashup of geothermal pilots that are happening in the field over the last few years. Many of these entities that are shown are actually going to be on panels today, so you'll hear from them. Many of the startups that are operating in the space right now are actually from the oil and gas industry, and they're jumping into geothermal and bringing an enormous skill set, a ton of knowledge, operational knowledge about how to drill wells, but they're also bringing the knowledge that they've built from the shale boom. And when I mean shale, it's the natural gas boom that has created, rearranged geopolitics and created oil and gas as a massive export for the United States, right? So in in that technological boom, we had the development of hydraulic fracturing, right? So everybody's heard of that. The little known technologies, though, are like directional drilling, new drill bits, the ability to turn and steer drill bits. All of these technologies help enable drilling for geothermal in much more places of the world. So we'll be hearing from some of these innovators today in panels, and many of them, and remember, this is a common theme, many of them are jumping from oil and gas into geothermal and bringing with them a hell of a lot of knowledge about the space. Okay. So that lays the groundwork here. Now let's talk a little bit about how geothermal can be utilized in all the different applications. This is another place that we're having a renaissance in geothermal right now. So there's all these different concepts that are popping up, but they all kind of fit into into buckets. So we can have a heating and cooling bucket and a power bucket. So let's talk about heating and cooling first. Geothermal is heat. You're producing heat from the subsurface. So it makes a hell of a lot of sense that you could use that heat for heat, right? Like, obvious. So geothermal for heating and cooling is just that. We are producing heat to the surface, and we're using it to heat buildings, right? So we will hear from entities like Bedrock today on panel that are working on these types of concepts: district heating systems, thermal energy networks. This is broadly known as shallow or direct use geothermal. You'll also hear it as low temperature geothermal. Whatever the terminology, it's shallow. It's typically used heat for heat and cooling, but this is a little less intuitive. We'll get to cooling in a second. Heat for heat, and it's cheaper, fully technologically enabled. We can do it now, and it's being done in a lot of places in the world. Europe is one place, and also increasingly in the United States. So that's shallow or direct use geothermal. Next up, cooling for geothermal. Okay, so it gets a little bit counterintuitive, but let's look at it this way, and you'll hear a lot about this concept today on panel, particularly with regard to AI. So, and data center development. Geothermal, if you've ever been into a cave, who's ever been into a cave? Okay, all right, cool. You remember it was cold, right? It's cold down there. It's 55 degrees Fahrenheit all year round. Geothermal for cooling is essentially using that shallow cool of the earth to cool things like space, in our buildings, like space cooling, but also a really hot topic is data center cooling. So using shallow geothermal cooling, absorption cooling to cool data centers. We just published a report with Rhodium Group, which you'll hear about today on a panel. It was just published today. Geothermal could power up to 100% of data centers. That's a huge deal. That's a huge deal, right? But a lot of the opportunity is actually in efficiency of data centers. So it's cooling the data center, which means the data center could use up to 50% less electricity than it would have otherwise, right? So one of the panels will get into this a little more, but think about the data center opportunity as a cooling opportunity first, so that's efficiency, and then later as a power opportunity, because that's also what a lot of the innovators on panel will be talking about today. All right, so that's geothermal for heating and cooling. One thing I want to say before we move from heating, and it's something that we're doing a lot in Innerspace, we're working on feasibility studies for this, is geothermal for industrial or process heat. That's usually higher temperature than building heat. We like it 70 degrees in buildings. Most process heat is 100, 200, 300 C. Pretty hot, but geothermal, again, it's heat, and as long as you're producing heat to the surface, you can use heat for heat. So geothermal for industrial processes, agriculture, yes, aquaculture, yes, but I mean chemical plants, paint plants, manufacturing processes. That's a really interesting opportunity for geothermal. And just as an anecdotal piece of evidence here, we partnered with a chemical factory, a big process plant that burns massive amounts of coal each year to make their heat. And just to pause for a second, that's how we make heat, y'all. Like for processes, we burn coal or natural gas to produce heat right now. And that's a massive footprint for carbon emissions. We partnered with a chemical factory in India to see what it might look like if we converted that factory from coal-powered process heat to geothermal heat. And we threw in also geothermal power into the feasibility study. And the outcome was awesome. Like payback period within 5 to 10 years, fully decarbonized heat and power. It was an awesome outcome, and this is something that can be replicated across all types of industrial processes. So keep that in mind as the panels proceed today. Okay, let's talk about geothermal for power. Geothermal for heat is 50% of the equation. Geothermal for power is the other 50. And you know, I've said this before. Power gets all the attention. It's because it's buzzy and it's very easy to understand. But as you go through the panels today, don't forget heat, because heat for heat is cheaper than heat for power. When you're making heat into power, you have conversion inefficiency, and it's a big one. So when you're producing heat to the surface and then having to convert that heat into electricity, you end up getting about 12% out of what you produce to the surface. So it's a pretty hard, it makes the economics of projects quite hard. In some places it works. In some places it's still too expensive. And so when you hear, you know, I was actually just here's another piece of anecdote. I was just in the bathroom and there was a group of women talking. And they were like, oh, geothermal, yeah, but it's expensive. I've heard it's expensive. Yes, it's expensive in some places for electricity, and that is because of conversion inefficiency. So you'll start hearing this in the panels too, talking about improvements in surface equipment, turbines, getting things to work better, research and development. That's what that's about. But let's run through what the concepts look like to produce geothermal power. So in Iceland, they produce geothermal power quite easily because remember, everything is close to the surface. You've got everything you need. Mother Nature has these perfect conditions. You've got heat, you've got water, you've got pore space, and you're able to produce a lot of heat to the surface and produce power relatively economically. In next generation geothermal, which is this catch-all term that means all the new shit all these entities are doing. Right, and like it's become such a big space that you'll see it in a slide in a minute. There's a lot of acronyms, but in next generation geothermal, essentially what we mean is you're engineering something that doesn't exist naturally in nature. So if you're engineering something that's not there naturally, you can call it next gen. And that means a lot of things. So say you don't have enough water in the rocks to produce enough output. You have to inject water or you have to inject an engineered fluid. That's next gen. Let's say you have to hydraulically frack your system because there's not enough pore space in the rock to make the output sufficient. That's next gen. Say you're using directional drilling technologies from the shale boom, and you're making you're making curves in your systems, and I'll show you that one in a second. That's next gen. So next gen is a really big bucket, but you can kind of think of it as using new tools, technologies, often from the oil and gas industry, to engineer something that doesn't exist naturally to make geothermal work. So this is a type of next generation geothermal system called EGS. And because we're in a renaissance, everybody has different terminologies. They even call EGS different things. You might hear it called engineered geothermal systems or enhanced geothermal systems. They mean the same thing. So it's the same. You're drilling 2 wells and you're fracturing the rocks, meaning you're creating the pore space that may not be sufficient naturally, enough to flow water in between the 2 wells. So you're injecting water, it's flowing through the fractures, through the hot rocks, and you're producing that hot water and steam to the surface to produce electricity. EGS, okay? Next up, let's take a look at super hot rock. So super hot rock, and this is SHR as the acronym that you might see, is a developing space within NextGen that imagines that we take the EGS concept, but we go way, way deeper and way hotter, right? And the hotter you go, the more energy dense your output. So these types of systems are looking to, compete megawatt for megawatt with other baseload energy sources like natural gas and nuclear. So you're talking about the ability to build big power plants on super hot rock concepts. These are not quite there yet, right? So I'm being gentle because we have so many startups in the room that will yell at me if I'm too hard on them. But super hot rock has some technological challenges that are yet to be solved. A lot of them are related to material science. The essence is shit melts when it gets really hot down there, and we need to fix that. Right, so there are a lot of different concepts to, and ideas about fixing that. How do we produce super hot rock concepts economically? How do we drill that far economically? And you'll hear about some of that on panels today. Next up, closed loop systems or advanced geothermal systems, all the same thing. AGS, CLS. The acronyms mean the same. Essentially, next gen, you're drilling wells, you're flowing fluid through a system without the hydraulic fracturing. And the reason you would do that, I mean, it's a harder, more expensive concept to pull off because you are drilling instead of fracking. Fracking is the easy way to produce pore space. Drilling is the more expensive way. But the reason you would do that is in places that you need social license to do geothermal, and fracking isn't a thing, right? So there are places in the world where hydraulic fracturing has been banned. There's places in the world where hydraulic fracturing is not popular. And there's a lot of, there would be a lot of protest from communities if there were hydraulic fracturing projects. Now, I will say as a personal opinion that I think that we should work on that as human beings and get over our hesitations about using these technologies for geothermal, because all of them together, the oil and gas technologies, if we use them to produce geothermal energy, my belief is that's a net benefit. But we have a lot to do in terms of social license, particularly with regard to fracking, because it's so emotionally charged. We actually have a panel about this today, so I won't spoil it, but it's about polarization and how we talk to each other and how we navigate these things. But closed loop systems eliminate some of those discussions. The balance, though, is that they tend to be a little more expensive. You have to go deeper and into hotter rock to get them to have the same output as EGS. This is the sum of all the different types of concepts that you'll hear about today. And by and large, let's look at what you're seeing. On my side of the screen is shallow, and when you're on my side of the screen, you're tending toward fully technologically enabled. We just need to figure out how to do a lot of it really fast. And this is going to be policy, incentives, education, but enabled. We can do thermal energy networks and district heating systems now, and we should be doing them all over the place. Then as you move further away from me in the chart, you get a little bit more difficult every step you take in terms of technologies that we need to deploy. You also get a little more expensive as you go, right? So as we move away from me in the chart, you get into when the super hot concepts where we need to do more research and development to get them to be economically feasible. But they're very promising for the future because they're really energy dense concepts. All right, so these are all the acronyms that you might hear today. I added a WTF at the end there. Essentially, what we're talking about, you'll hear them all, but what I want you to remember throughout the day is that this happened in shale, where we had this renaissance, this technological flourish, and there were all of a sudden all these technologies and all these acronyms and all these teams in the field doing all these different things, and that was amazing because it rearranged the world. For natural gas. And we're seeing the beginning of this now in geothermal, and it's really, really exciting. So as you hear about all this, keep that in mind, that everybody is differentiated and trying something a little different and trying to get geothermal to work. And that's a really exciting moment for geothermal. Okay, so let's talk about, for really quick to end, what the impact of all this would be if we get it to work. And this is like my favorite topic. So right now in the world, we drill for oil and gas at a rate of about 70,000 wells per year. That's globally. So we meet world energy demand with a lot of things, but most of it is oil and gas and coal. And to do that, we drill 70,000 wells a year. If we were to drill geothermal wells at that rate a year, so 70,000 geothermal wells a year, by 2050, we will have met almost 80% of global electricity demand, and I mean future demand, not today's demand, and more than 100% of heat. So that's literally fixes everything. It fixes energy. It's huge. But there's a lot of things that need to happen between where we are today and that outcome. Mostly that we need to get the oil and gas industry excited about stepping in and scaling geothermal and doing it in a serious way at scale, right? But massive, massive potential. And you can see it like many people in the world, this is the 77 and 100%. Sorry, my slides are a little laggy. When you look at where geothermal is right now, y'all, this is the slide from earlier. I'm sorry. Let's talk about that for a second. You can't do steel with geothermal. So a lot of people will, I'm sure you'll ask in terms of heat. Oh, well, what about the really high temperature stuff that we can't figure out how to decarbonize? Not yet, but ask a super hot person what they think about that. And that's why they're going for these super high temperatures and these concepts. So in the future, not right now. Okay, sorry, it's a little scrambled. Okay, so if you look at where geothermal is right now in the global energy mix, it's in the other category. So it's in that one, the little green one. Nobody knows or cares about geothermal, and it's been that way for 100 years, right? So geothermal has been a cottage industry, stagnant growth, about 1% growth. Even if we grew geothermal 50 times what it is now, it's still just about zero. I mean, it's literally a nothing burger in our energy mix. And so that gives you an idea of how fast we would need to grow this industry to make a dent, right? We're not talking 20 times, 50 times, not even 100 times. We'd need to grow it thousands of times, 10,000 times, 100,000 times to start even making a dent in what we need. And for that, we're really going to have to lean on the oil and gas industry, right? So workforce, the speed and scale of the workforce, also technologies, the global footprint of oil and gas, et cetera. And so you'll hear some of those themes come out in panels today too. What it would mean to build a business model where oil and gas is actually able to make money building geothermal, right? And what that would mean in terms of our ability to go fast. Okay, I think that's it. So thank you all for listening. If you need anything in Geothermal House or have questions, find an interspacer and we're all happy to help. I hope you enjoy the panels and stick around for today, and we'll see y'all later. Thanks for coming to Geothermal House.